X squared should fly. Yeah, 4 over 15. Secant u then you.
Alright, let's see if you guys are matching up with what I got.
Yeah, the 4 15 comes right out. Derivative of tangent secant u plus c.
No, let's go ahead and write
We gotta plug in, we gotta substitute using our little equality statements. Therefore, hopefully you got the integral, the new integral after substituting to be 4x squared secant of u tangent of u times du over.
15x squared.
Can anybody cancel?
No, x squared.
X squared can't. Oh no, 4 over 15. It's messing
4 out.
everything up except it's a constant. What can I do?
Take the constant out.
Got it. Now I have the integral of secant of u tangent of u du. My variable in the differential, du, matches my variable in the function. There's no extra x's messing me up. Therefore, I can just integrate. Anti-derived secant tangent. What do I got? Secant. Keep the same variable. 4/15 is still chilling. But we're not done until we say, uh-oh, who is you? Plug it in to finish your answer of 4/15 secant of 5x cubed plus c. Dun, 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 dun. Questions? The name of the game is who is you, who is du, plug it in and hopefully solve with the basic rule. Right? Now, can this get any more exciting?
Yes.
Oh yeah, it can.
Integration on crack.
Math is better than drugs. Anyway,
Honestly,
Matemáticas es mejor de drogas. So here we go. Integration on by substitution. Integration can be on it. You can't. Here we go.
You're 100% right, by the way.
Yes, thank you.
It is better than.
I
It's like,
I thought it was the other way around. No.
These really hard problems, and then when you solve it and figure out it was right, I swear.
Remember, we're trying to choose wisely, not only in math, but also in life. Here we go.
It's so funny.
You need to read your Bible. Okay, so. A question. Don't stress about the craziness that you see in the title. Don't stress about the craziness. Wait, pause. Who would you make you?
X minus 1.
Yeah, right? From all that we've done. So let's see why on earth this is so much harder. U is equal to x minus 1. Who would du be? 1 dx, right? The derivative of x is 1. The derivative of negative 1 is 0. So now we say, what can we plug in? And we say, oh, hey, you know what? We have this dx guy we're going to plug in for him. And we have this
Oh, I see.
u guy that we're going to plug in for him. Right? So we go plug it in. We say, no big dealio. Our new integral will be the integral of, focus, x squared, square root of u times du. That's impossible. I need only u's. I have a random x squared. There's nothing I can do. Well, no. There's more that we can do.
Try. Crap.
In all the other examples that we have done, this was enough. Substituting what we had for u, substituting what we had for du, and if we needed to, we could solve for dx. But if you guys notice, when you solve for dx, dividing by 1, it doesn't really help much, right?
Nope.
It's the same thing. Hence why I just plugged it in. But what we haven't realized is we can also rearrange this guy. Not only can we rearrange by solving for dx, but we can also rearrange by solving for x. In terms of u. It's getting a little crazy, getting a little out there. Good, life lesson. It's crazy substitution. So, we say, you know what? We had this guy who was kind of stuck down here when we needed to substitute, and we say, hey, we have somebody to substitute with. So we had to think outside the box. The math had to get a little crazy, but we're staying sane and wise and in control. And we can say, okay, let's plug it in, plug it in. Now what integral do we have? The integral of u plus 1 squared. I'm just encouraging wise choices. Oh, no, it's not any more possible than it was before. Oh, it's way more possible. Wait. You've done integrals like this. Last chapter, chapter 4a. Basic integrals like this. Wait, what? We did? How? Earlier, what was in the square root was a u. That wasn't working out. But now all that's in the square root is a u. Wait a minute. Hold on. Can't we FOIL out? Don't kill a puppy. Can't we FOIL out? And can't we then distribute? And can't we make this just a simple sum or difference? 2 plus a half. 2 plus a half. 4 halves. Plus a half would be u to the 5 halves. U to the 1 plus a half. 2 halves plus a half. U to the 3 halves plus u to the 1 half. This is totally solvable. We just have to go back to what we were doing before with the craziness of multiplying out. So now I add 1. Add 2 over 2. That's 7 halves. That would be 2 sevenths. U to the 7 halves. Wait, who is u? Can we do this now? Yeah, let's plug it in. So x minus 1 to the 7 halves plus 2. Hold on. We're going to need to make it to the 5 halves, right? We have to add 1. 5 halves needs to be offset by 2 fifths times 2 will be 4 fifths. I'm doing a lot of math at once because I'm running out of room. Plus u to the 3 halves, which will be x minus 1 to the 3 halves,
2/3.
times 2/3.
Let's
Let's
see.
see.
Boom.
Dun, 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 dun. Except the AP would never leave it like that.
But we can.
Boo.
What? That looks beautiful. No, it doesn't. It looks awful. So how on earth, what on earth
Oh, multiply
Would
by
they-
like 35.
do?
I swear if it would have
Yeah, first of all, we have 3 different fractions that are really messy and ugly, and who wants to have fractions? Nobody. Second of all, are there any shared powers of x minus 1 in the terms without c? Now I'm going to go a little crazy because I ran out of room. So I'm going to go up here, sideways. Let's see if you guys can track. Don't worry, you got this, kind of, sort of, maybe not. What would be a common denominator with
35.
sevenths, fifths, and thirds?
35 times
No.
37.
3 doesn't go into 35. 35 times 3, that kind of works. 21,
It just
42.
didn't have to be
Let's keep on going.
6.
We can do 35 times 3. So 35 times 3 would end up being 5 and 1, 105?
Yeah.
Is there anything lower than 105?
No.
Okay. So we do 105th, 105th, 105. Ugh. What's 7 into 105?
That would be 15. Yeah,
And
but
meanwhile, I'm going to pull out the x minus 1 to the 3 halves because everybody has that in common, right? Oh my goodness. 7 goes into 105 how many times? 15? 15 times 2 is 30. So we have 30 105ths times, if we take away x to the 3 halves from x minus 1 to the 7 halves, how many halves do we have left? 4. So which, wait, 4 halves, that's the same thing as
2.
squared. That's nice. And then I have plus, how many times does 5 go into 105? 21 times 4 would be 84 105ths. Take away x minus 1 to the 3 halves from x minus 1 to the 5 halves. That'd be 2 halves, so would that be just x minus 1, right? And then plus 3 into 105. 35. 35 times 2 would be 70. 1/5. Take away x to the 3/2 from x to the 3/2. Well, that's gone. Plus c. Well, that looks so much easier. Just kidding. But wait. Can't we now take out the 1/1/5? And can't we also do something like 30 is left, times x squared minus 2x plus 1, plus 84x minus 84 plus 70 plus c? What am I doing? I took out all the 1/5 and I took the little 84 and I said, hey, you need to distribute, and I took the little 30 and said, well, you need to go into him. So then I end up with a final of, bless you, 30x squared minus 60x plus 84x, which would be plus 24x, right? Negative 60 plus 84 would be 24. And I have 30 plus 70 is 100, minus 84 is 16. Bless you. Plus c. Oh my goodness, now there's a common factor. I can take out of everybody what? 4? No, 2? Oh, that's it? That's kind of lame. So I can take out a 2, and all of a sudden, this all is going to become 15x squared plus 12x plus 8. Take out a 2. Can that factor? 18 and 8. No, 15 and 8. What does that become? I should know this. 4 15s and 4 is 60. 4 and 2 is 120. Is that right? 15 times 8. Oh, I still have a calculator, but he's kind of dead. Wait. 15 times 8. 15 times 120. Are there any factors of 120 that add up to be 12? Oh, none? You already checked? Lame sauce. Alright, so I guess we're done.
Yes.
So final answer, 2 1/5.
The never-ending math.
X minus 1 to the 3/2. 15x squared plus 12x plus 8 plus c. Dun, 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 dun. Now, heads up! This is usually, actually, listen. This is a very common AP problem, but theirs would be a little bit simpler. It's a very common AP problem for us to have this nasty, like, hey, there's x's, no, there's u's raised to all these powers, but there's a shared power, and because it's a shared power, we pull it out, and when we pull it out, then there's like a shared fraction, common denominators, we pull that out. And usually, this factors to become something really nice and pretty that you would never match this nasty thing to, unless you did the math. Anyway, quick heads up. They love to factor out what's in common. All right, cool kids. We're not stopping there though, because we still have 3 minutes.
Yes.
Ready, set, go.
Would something like that be like one of the smaller, like 4-point FRQs? Really?
But the math would be a little bit shorter.
Right.
Probably as nasty numbers.
Okay, cool.
Ready, set, and go.
Okay, so one of our blue response questions was a picture of a burette, and they're like, how much fluid is in here? I'm like,
I remember that one.
give me 3 points.
I had to like look at it for a second. Like, sweet.
I'm giving you guys exactly 15 more seconds before I start busting it out. You should be figuring out who is you, finding du, maybe solving for dx, and then going back and solving for x, and then plug and chug as best you can. Who is you? Find du, solve for dx, go solve for x, and plug and chug as much as you need. My turn. This is a bit more like an actual AP. There's only 2 pieces, it's not quite as bad. You guys did awesome. We have one more day on Monday to go over the final steps, but guys, you have seen examples like all of the integration of the first half to 2/3 of homework. Work on integrating with USub over the weekend. This homework is due on Tuesday. You just want to have a few extra left to do. You can do the bulk of homework. It is online. I'll see you guys later. Happy Friday! Bye, guys.
Friday.